Well friends, so today's your topic is parallel plate capacitors. So have a quick look about what is a parallel plate capacitor. So I have drawn a rough sketch of parallel plate capacitor. You can see these are two plates which are parallel to each other. Uh, they are like this actually, and inside this, um, between this, there is a medium with high dielectric constant. What is dielectric constant we'll mm, discuss later. And one of these plates are grounded, and this is what is a parallel plate capacitor, and now we'll see how it works. So let's consider this a parallel plate capacitor. um, Actually we are seeing those plates vertically, so from this direction. Now let's consider that area of each plate is A, and this place is grounded. Let's think that this parallel plate capacitor is charged by joining with the battery, and then it is removed. So what we will see in this grounded plate, the plus charges will go into the earth by this ground, and only remains minus negative charge which will remain in other side of the plate. And we all know the induction that will cause plus charge here. So what is induction? We know that when a negative charge is introduced um, in front of our neutralized body, then positive charge is formed in the body, and they attract each other. So by with this way, positive charge will form in this plate, and negative charge will remain in this plate. So now we're gonna calculate the capacitance of this parallel plate capacitor. So we know this formula, C equal to Q by V, where C is the capacitance, Q is the charge, and V is the potential. So to calculate the capacitance of this parallel plate capacitor, we have to calculate Q and V of this capacitor. So you can calculate Q by sigma A. Q equal to sigma A. Now what's sigma? Sigma is the charge density in area, I mean areal charge density. That means there is sigma charge in each unit area. So Q, here you can get Q is sigma A, and now let's calculate V. So Q equal to sigma A. We know the formula that E equal to minus dV dx, where E is the electric field intensity, and V is potential, and X is separation. So from this formula we can get dV equal to minus E dx. So from this, by integrating, we have to calculate V, or V equal to minus integration E dx. Actually this separation is D, it has to be told, so we have to integrate from D to 0. So now we have another unknown E, so we have to calculate E. From Gauss formula we know that closed integral E dot ds equal to Q by epsilon 0, or we can write from this closed integral E, actually mod of E and mod of ds dot, we can see that here E and ds are perpendicular, parallel, so we can write cos 0 degree equal to Q by epsilon 0. Now let's act with E as a constant and take it outside of the integration. So E closed integral ds equal to sigma A. So why I wrote sigma A? Actually Q is the charge, and we told later that sigma is the areal charge density and A is area of the plate. So for one plate, charge stored is sigma A, and here epsilon 0. So from this we can get E A equal to sigma A epsilon 0. Here S is the area, so S treated as area, and integration ds becomes A, area of the one plate. So let's cut, and here E becomes sigma by epsilon 0. So here we can get sigma by epsilon 0. So from here we can write V equal to minus sigma by epsilon 0. Actually sigma by epsilon 0 is not a function of x, so integration dx d to 0. So we can write from this, let's clear it, V equal to minus sigma by epsilon 0 x lower limit t upper limit 0. So it becomes minus 0 minus t and minus minus becomes plus. So sigma t by epsilon 0. So here we can get both two values of q and v. So let's apply these two into this equation. We can get C equal to Q by V, or C equal to Q means sigma A and V means sigma D by epsilon 0. Now let's cut sigma, and it will go to the up, and A epsilon 0 by D. So it's the capacitance of the parallel plate capacitor, and we assume that the medium between them is vacuum. We know that electropermittivity of a vacuum medium is epsilon 0, and if we have to calculate of any medium, we have to work with a K dielectric constant. So electropermittivity of any medium epsilon equal to K epsilon 0. I will prove it in my later sessions. So this is electro and K is dielectric constant. So from here we can generalize this formula by making it, let's write C general equal to a K epsilon 0 by D. We know that A and K does not, A and epsilon 0 does not vary, but K and D can vary. So C general equal to A epsilon 0 by D by K. So as we have a capacitor like this, having electropermittivity of K1 in this region D and K2 in this region, let's take this D, this full region D, and this X. So let's ground it, and the new capacitance will be C equivalent equal to A epsilon 0 by D minus X by K2. So D minus X is this, and this has electropermittivity of K2, and plus X by K1. So X region has electropermittivity of K1. So you can generalize with this formula with this, and if K1 and K2 equal, so K1 and K2 equal, it becomes A epsilon 0 K by D minus X plus X. So from this we can get this formula. So we have studied how to calculate the capacitance of parallel plate capacitors and what are parallel plate capacitors. In my later sessions I will show you practically how capacitor works, and we will go through by cylindrical plate capacitor and any other like capacitors we have. So goodbye, and don't forget to like, share and subscribe. Please support my channel because you know that it's a new channel, and goodbye.